Welcome everyone. Um, in this applications of derivative, we'll try to understand with a simple real life example. In the picture we are seeing here a simple soft drink can. We can also assume this as a cylindrical in the shape in the sense that the height of this can is, let's say, h, and the radius is, let's say, r. So we can define the volume that can be contained by this cylindrical can will be pi r square h. And let's consider the case that we are defining the volume, let's say 200 ml. We are targeting this soft drink can, and we want to minimize the cost of manufacturing of this can. So as one can understand that the cost of manufacturing of this can is directly proportional to the material used, and the material used will be again proportional to the cross-sectional area. So if you write the cross-sectional area of this uh, soft drink can, it will become 2 pi r square plus 2 pi r h. And the first term is the summation of the top and the bottom area, and the second term is the circumference area. And if we substitute this h from the first volume term to the area term, we can rewrite area as 2 pi r square plus 2v by r. Because we are assuming that the volume to be contained by this can is constant, so we can write it in this way. And to optimize this area, in order to optimize again the cost, we have to take the first derivative, so it will become dA by dr. We will take with respect to the r because r uh, is a single variable in this equation, so it will solve as 4 pi r minus 2v by r square. For the optimum condition, we have to equate this first derivative to the 0. So here if we solve it, it will give r as v by 2 pi to the power 1 by 3. And if we substitute this r into the first term, we can get the corresponding h, that will be 4v by pi to the power 1 by 3. So this set of r and h is actually corresponding to the surface area, which is the minimum. If we alter this r or if we alter this h, then the respective can which will be manufactured will be of more price, because the cross-sectional area will be more. And also we want to get sure that this first derivative which we have calculated, is it signifying to the minimum point or the maximum point. So just to confirm it, if you take the second derivative with respect to the r, so it will become 4 pi plus 4v by r cube. And one can see that this term is always positive because r is always positive for the CAM design. So we are confirming here that this is a particular set of r and h which will give the minimum price for the design of this soft drink can. So it was just a simple example to demonstrate the application of derivative. Thanks for your attention.